Okay, let's have a look at some chemical maths. These are kind of more problem solving questions, but they technically kind of still are calculations. They are difficult because they give you so many pieces of information. You need to try and sort out what the information is telling you and also what the question's asking. And then there's going to probably be some difficult units in there as well to make you think. So they are difficult. It's like if you're trying to juggle, your memory is a wee bit like juggling. If you've maybe got about 3 balls you're trying to juggle and you were a good juggler, you could probably manage it. But if you try to take it up to about maybe 4 or 5 or maybe even 6, it's a bit too much. So I think with these ones, let's look at this one for example, it's about maybe taking the information you see and just kind of like highlighting it and then trying to sort it out. So it says coumarin is another compound found in the brand name perfume. It's present in the spice cinnamon and it can be harmful if it will be eaten in large quantities. It then says the European Food Safety Authority gives a tolerable daily intake of coumarin at 0.10 milligrams per kilogram of body weight. Now, anytime I see a number when I do these, I underline it just because then the numbers are kind of jumping out at you and it makes it easier to understand what the question's asking. I'll come back to that. It then says 1 kilogram of cinnamon powder from a source contains 4.4 grams of coumarin. So 1 kilogram has 4.4 grams, and then it's asking you to calculate the mass of cinnamon powder in grams, which would need to be consumed by an adult weighing 75 kilograms. So there's quite a few pieces of information happening here. We've got the 0.10 milligrams per kilogram of body weight, that's the tolerable daily intake. We've got the 1 kilogram of cinnamon powder containing 4.4 grams, and then it's also telling you that we're trying to work this out for somebody weighing 75 kilograms. So what I would first do is there's obviously going to be this part, 0.1 milligrams per kilogram of body weight. Let's work out what that actual mass is. So that's going to be 0.10 milligrams of coumarin per kilogram. That means that somebody weighing 75 kilograms, that is going to be 0.10 times 7.5. That's going to be 7. Sorry, my bad. I've actually done that in my head before I've even done it. That's 75. So that means that's going to be 7.5 milligrams in total. For somebody weighing 75 kilograms, they're going to have 7.5 milligrams. We can make this easier for ourselves moving forward because it does say calculate the mass of cinnamon powder in grams, which would need to be consumed. And because it's asking for grams, I'm actually going to change this to grams to make it easier for us. So that's going to be 7.5 times 10 to the minus 3 grams. Just using the scientific notation, milli is times 10 to the 3. Let's look at what else we have. So we're going to try and work out how much we need to get of the cinnamon powder to have that amount of mass of coumarin. It then tells us that 1 kilogram gives you 4.4 grams, so it's going to be 4.4 grams in 1,000 grams cinnamon powder. That means that the mass that we're trying to find, so the 7.5 milligrams, or 7.5 times 10 to the minus 3, is going to have, or we're going to have to take in 7.5 times 10 to the minus 3 divided by 4.4. This is a proportion thing, so 4.4 grams would give us like 100 grams or 1,000 grams of cinnamon powder. We're trying to find out how many grams of cinnamon powder we would need to have to give us 7.5 times 10 to the minus 3. So we're using proportion, it's like nu over old times the other side, and we did that when we were looking at enthalpy of combustion. So let's do that, and that will give us, and then we need to times that by 1,000, that's the other side, and that will give us a nice little answer of 1.7 grams. And that's the answer for that. So the mass of cinnamon powder in grams, which would need to be consumed by an adult, would be 1.7 grams. So using that proportion from there, that will let you do it. What I'll do is I'll let you pause here. If you need to have a look at anything and maybe go back, you can also rewind these just to see where that's coming from. But I did 2 steps there. I tried to work out the mass of coumarin for somebody weighing 75 kilograms, which we did here. And then I know that 4.4 grams of coumarin is going to be in that 1 kilogram, the 1,000 grams of cinnamon powder. So I'm working out how many grams of cinnamon powder, that's what I did, the 1.7, for the 7.5, that's the limit, if that makes sense. So it's just about looking at what you've got and trying to organise your thoughts and stuff to make it easy to do. Let's try another one. So we've got squalene, this is a triterpene, so it's a terpene, potentially got 3 terpene units in it somewhere, maybe joined together. That's actually not going to make a difference to our question, but it's included in some flu vaccines to enhance the body's immune response. A single dose of flu vaccine contains 10.69 milligrams of squalene. What I'm going to do here is I'm going to underline that because that sounds to me as if it would be important. Then it's asking us to calculate the mass of squalene required to produce a batch of 500,000 doses of flu vaccine. Let's just have that as well. So our answer must be given in kilograms. So again, this is a case of looking through these and just looking at what it's asking. So it tells you a single dose has 10.69 milligrams. So let's write that in. And this is tricky, not because of what they're asking, but it's because it's in kilograms. So you're going from milligrams into kilograms. So let's just work it out. Let's just go for it. So we know that 1 dose contains 10.69, then 500,000 doses must contain 500,000 times 10.69. That must mean that it contains 5,345,000 milligrams of squalene. Therefore, if I'm wanting to go to milligrams, let's change it into grams. So there's also, so milligrams is 10 times 10 to the minus 3. So if I want to go to grams, then I need to divide it by 1,000 to get it to milligrams. Sorry, to get it to grams. So I can take 3 zeros away. So that's going to be 5,345 grams of squalene. And then if I want to make that into kilograms, again, it's going the same way. Kilo is times 10 to the 3, not minus 3 for this. So again, you're taking off 3 zeros, except we've got numbers there, so we can't do that. So let's go 5.345 kilograms of squalene. So divide it by 1,000 each time. There you go. And that's how we do that. So that's the final answer. So the only problem with that one was the units. Let's try another one. So it says the minimum concentration of ethane thiol in air that can be detected by humans is 2.7 times 10 to the 7, 2.7 times 10 to minus 7 milligrams per centimetres cubed of air. This is a concentration, and it's awkward because it's in 2 things that you would normally measure concentration in. That's milligrams instead of like moles per litre, and centimetres cubed instead of litres, which we'd usually use. Doesn't matter though, we can still do it. And it says calculate the minimum mass of ethane thiol that needs to be present in a room containing 43,900 litres of air in order for it to be detected. So let's write this out. Let's take the information we need. So let's do the minimum concentration, and that's going to be 2.7 times 10 to the minus 7 milligrams per centimetres cubed. That's fine. Then what we're going to do is we are going to work it out now for the volume. So we know that 43,900 litres. The reason I'm going to do this is because I need to try and get it into these units, milligrams per litre. So what I can do is I can then make that into centimetres cubed. So if you know that a litre has 1,000 centimetres cubed in it, then that's going to be 43,900. So 43,900,000 centimetres cubed. So it's a case of times them by 1,000 to get it from litres into centimetres cubed. That at least gives you something that you're working towards. So that means we can work out the number of milligrams for that centimetres cubed. So our mass needed is going to be 43,000 or 43,900,000. So that volume in centimetres cubed. And then if it's telling you we need this concentration per centimetres cubed, this is the amount of centimetres cubed, the 43,000. That's the volume we need. So let's do that times by 2.7 times 10 to the minus 7. And if you do that in the calculator, you end up with 11.853 milligrams. And that's your final answer.